My name is Alex Galt. I'm a math teacher at Edina High School, and today you are going to be composing functions in a real-world scenario and trying to understand what that means for that scenario. Okay, in Minneapolis, the sales tax is 6.875. A function for calculating the price of an item after sales tax that costs X dollars is 1.06875 times X. So that tells you the price of your item after you add the sales tax amount to it. The reason this 1 is here is because you still have to pay for the item, so you're really paying 106.875% of the price of the item because you have to pay for the whole item plus the sales tax. A store charges $50 for delivering big items. A function for the cost of an item with delivery that costs X dollars is X plus 50. So the first thing they're asking you to do is to figure out what P of C of 100 is, and really it's important to understand what that means. That means that we're going to do C of 100 first. I can almost do C of 100 in my head. C of 100 will be 100 plus 50, which is 150. And then I take my answer of 150 and I put that into the P function. So I do P of 150, which means I'm going to have to grab my calculator and do 1.06875 times 150. And I get 160.18. And then the other question is, what is C of P of 100? And maybe at first you think, well, they must be the same thing. But P of 100 means I'm going to pay the sales tax first, and then I'm going to pay for delivery. So I'm going to do the sales tax function. I'm going to do P of 100. Since that's multiplying a decimal by 100, I just actually move the decimal place. So that'd be 106.88 if I round it for money. And then I take that answer and I plug that answer into the C function. So I'm going to do C of 106.88. So it's going to be 156.88. And so what I notice is that if I pay the sales tax first and then I pay for delivery, I pay less money than if I pay the delivery charge first and then I pay the sales tax. Because this function was doing C first and then doing the sales tax, and this one was doing the sales tax first and then doing the delivery. So the question says, is it a better deal to pay for delivery first or pay sales tax first? It's better to pay tax first, because you will wind up paying less money because you don't have to pay tax on delivery. Okay. And then we also learned in a previous section how to write an equation if you have, if you want to write this as a function. And so this time I think of P as the shell and C as what we're going to put inside the shell. So the P function is 1.06875 times X, and that's the shell, and then we're going to put C into that. So we're going to put X plus 50 into that shell. I don't want you to stop there. I do want you to finish by distributing. So you wind up with 1.06875 X plus 53.44. And then the second question is, what if we do it in the other order? What if we do C as our shell? So we have something plus 50, and then we put P into that shell. So that's going to be 1.06875. I wish sales tax were easier, so I wouldn't have all these decimals, plus 50. This one doesn't really have any simplifying that I can do because I don't have any distributing, and they're not like terms. So I just wind up with 1.06875x plus 50, and now it's really easy to see that this is a better deal because it's exactly the same, except I'm adding more on to the same number if I do the delivery charge first. Okay, it's important to understand what your functions mean. And so what this means is we're paying for delivery and then we're paying sales tax. And this one means we're going to pay for sales tax and then we're going to pay for the delivery. The rest of this section's notes is a review of the previous lesson. But if you didn't understand how to do composite functions from a table, this is a good chance to get that down. So if I'm going to do a of b of 4 from the table, remember this means that 4 is the x-coordinate. We're going to plug that x-coordinate of 4 into the b function and we get 6. So then we're actually finding a of 6, but now 6 is the x-coordinate for the a table, so then we wind up with a of 6 is equal to 11. Okay, for letter B, our x-coordinate is 1 in the a table, so if x-coordinate is 1, our y-coordinate is 7, so we're really finding b of 7. And then the x-coordinate is 7 for the b table, which means that we're at 15. That's kind of the process. You're just kind of jumping through both tables. So you should get b of 3, which is 2, and then you should get a of 0, which is 5 for the rest of those questions. And then these problems are a reminder about how to write functions that are composites of two other functions. And I like to think of the outer function as the shell, and the inner function is what you're putting in the shell. So if I look at just the a function at first, the a function as a shell is 2 times something plus 1, and then I'm putting inside of that shell, I'm going to put 3x minus 5, because that's the b function. And then from there I want to make sure I distribute, so I have 6x minus 10 plus 1, which would be, if I add like terms, 6x minus 9, and that's my new composite of two functions. So if I look at number 2, my shell is going to be the b function, so I want, I'll use blue to be consistent, I want 3 times something minus 5, and the something is 2x plus 1 because that's the a function. And then you make sure you distribute, so you have 6x plus 3 minus 5, or in other words, 6x minus 2 is your resulting function. I think it's easier when you have a number not to go through that whole process, but instead to start from the inside and say, here's the x-coordinate for b, so I'm going to look at the b function and I'm going to find b of negative 2 first. And so when I do that, I get negative 6 minus 5, or negative 11, and then I plug negative 11 into the other function, so I'm going to do a of negative 11, and then I get negative 22 plus 1, or negative 21. So when it's a number, I prefer to just jump through the functions, but if I have x's, I think of it as putting a number into the shell. So that, putting a function into the shell. So a of negative 2 would be 2 times negative 2 plus 1, so negative 4 plus 1, which is negative 3. And so then I want to find b of negative 3, which would be negative 9 minus 5, or negative 14. You should be getting to the point where it's comfortable for you to write composites of functions as a function, and you should also be comfortable evaluating composite functions.